Welcome to Escape Velocity Space News. I'm your host, Dr. Pamela Gay, and I am here once again to put science in your brain. Putting this episode together has been a bit of a wild ride, and we actually delayed the episode for 1 week because I was hoping to see some of the stories on our list to cover come to some kind of a resolution. But no. 5 extra days later, we're still not sure how a lot of stories are going to turn out. Hubble's budget is still slashed, and we still don't know how those cuts are going to be implemented. Chandra's budget is trashed, and we're still not sure if the mission team is being laid off. And it just goes on and on. Instead of talking about the unresolved future of these missions, we're going to explore exoplanets in our first segment before we take a deep dive into the story of the Viper rover's cancellation and touch a bit on what we do know about Hubble and Chandra and their budgets of sadness. And speaking of budgets, most years we do a massive fundraiser, our Hangout-a-thon, to raise money to make up the difference between what we earn through Patreon and what we need to pay our bills. This year's event is going to be October 18th through 20th. If you want to help it be a success, please join our Patreon at patreon.com/CosmoQuestX. We're also doing some gaming weekends prior to the hat as we build enthusiasm. We'll be posting details on Patreon and social media as dates approach. But first, we have science and space exploration news coming to you right here, right now on EVSN, a product of CosmoQuest. Anyone who likes to exercise outside can tell you the sunrise side of the day is far cooler than the evening twilight. Here on Earth, with our rotating world, this is easy to understand. Throughout the night, our planet radiates away the heat of the day to outer space, and that cooler part of the planet then rotates back toward day. This is an imperfect process, but it is efficient enough that I'm willing to bike ride in the early morning light, even in the peak of an Illinois summer. For tidally locked worlds, this kind of a nighttime cooling never comes to pass, and differences between dawn and dusk can have very different physics. Tidally locked worlds orbit around their stars at the same rate that they revolve about their axes. And the same point on the planet is always experiencing noon, while the midnight point on the planet sees the stars change very slowly as the planet moves in its orbit. Without an atmosphere, the temperatures on every point of this kind of a planet should reach a steady state that depends strictly on how light hits and heats the planet, and on how that heat may radiate through the landscape of the world. For worlds with an atmosphere, however, things can be different. Standing wave patterns in the atmosphere are able, in ways that aren't fully understood, to trigger powerful eastward winds that flow from sunrise towards sunset. In this situation, cold air from the night side can be carried into the day side. And similarly, hot dayside air is carried over the sunset and into the night side. In addition to affecting temperatures, these winds also affect clouds and weather. Variations have been predicted for tidally locked worlds since at least 2002, and only today with JWST are we able to observe the details of what is going on. And so far, we can only do this with one world, which apparently I'm going to keep updating you on. That world is WASP 39b. In a soon-to-be-published paper in the journal Nature, researchers led by Nestor Esposito look at our old favorite, WASP 39b, and the carbon dioxide, water, and other atmospheric molecules that fill its atmosphere. They find that the ratios of carbon to oxygen atoms are similar to what we see in our sun at both the planet's sunrise and sunset terminators, but the atmosphere is thicker on the morning side. This is consistent with the morning horizon being 177 degrees Celsius cooler than the sunset horizon. These measurements are consistent with planetary atmosphere, general circulation models, and cloud models. This research is part of JWST's Transiting Exoplanet Community Director's Discretionary Early Release Science. Designed to gather the data needed to transform our understanding of planets and the origins of life, this program is gathering data on a variety of worlds and releasing it directly to the science community for analysis. I, for one, am eager for this program to deliver work that leads to papers on worlds in addition to WASP-39b. As of the day of this recording, August 8th, 2024, more than 5,600 exoplanets have been discovered orbiting more than 4,000 alien stars. With these systems, we are regularly finding things our experiences with our own solar system never prepared us for. From tidally locked worlds to hot Jupiters, our universe is more creative than any of our theories predicted. And today, researchers work to sort just how each of these wild worlds can come to exist. Consider hot Jupiters. So far, we've found 300 to 500 worlds with a Jupiter-like size in an orbit similar or even significantly smaller than Mercury's. Many of these worlds are unlikely to survive for the billions-year-long lives of their solar systems, and they couldn't have formed in these overly hot and violent locations either. We are simply catching them in a special moment of time when they are roasting in the light of their stars. Since the first hot Jupiter was discovered in 1995, researchers have been trying to explain how they got there. Our best theories predict these worlds interact with material in their solar system's disks and migrate inward due to these interactions, or they migrate due to gravitational interactions with another object, such as a second star in the binary systems. To demonstrate these theories, however, planets have to be caught in the act of migrating, and that just hasn't happened, at least not until now. Observations of the transiting exoplanet TIC 241249530b with the ground-based WIND telescope discovered just the right kind of weird orbit to be what scientists have been looking for. This planet is currently orbiting backwards relative to its solar system, and it has an orbit that, if scaled to match our solar system, would have it going from as close as Mercury to as far from its star as Earth. The star also has the kind of distant companion that can cause migration. According to models presented in a new paper in Nature led by Avind F. Gupta, everything is consistent with gravitational tidal forces driving the planet into the center of its solar system. Over time, it is expected that this highly eccentric orbit will transform into a more normal circularized orbit. I have to admit, my first thought on hearing the orbit was backwards, was to search the paper for the possibility that the planet was captured as it wandered by. The possibility isn't discussed, and after thinking about it, I have to admit that planetary capture would be so unlikely that if a much simpler planetary migration fits the data, that is likely the answer. But if you were wondering about that planetary capture idea, I was with you. Every telescope has things that it is designed to be good at, and things that its design happens to make it really bad at doing. And thanks to a newly delivered coronagraph instrument built by the Max Planck Institute for Astronomy, NASA's Nancy Grace Roman telescope is going to be designed for finding planets like Earth. The coronagraph will block light from a star before it can reach the telescope's camera and make it possible for the light of fainter planets to be directly detected. This delivery brings Roman one step closer toward launch in May 2027. After the break, we're going to look at the Viper lander, NASA's rash of mission cancellations, and how we got here. Stay tuned. Throughout this segment, we're diving into the probable cancellation of NASA's much-anticipated Viper Moon rover. This is an extremely complex topic, and a full discussion just isn't possible given the limited length of this segment or even this show. To give this story the space it needs, I'm creating a series of articles over on Substack that examine the different economic and political factors that are at play when it comes to NASA budgets, contracts, and mission selections and cancellations. In preparing this story, I sent requests for information to various NASA offices, including requests for specific guidelines and documentation that shaped NASA's decisions. These emails were sent on or before July 26th, and as of the time of this recording on August 8, I haven't received any answers. The past few months have been hard for everyone following NASA missions. Issues in the U.S. Congress led to significant delays in the FY24 budget allocations. While everyone was waiting, NASA, along with most of the U.S. government, had to move forward, and they assumed a budget that would meet or exceed that of the prior fiscal year. In early March, 5 months into the FY24 fiscal year, the budget was finally allocated. Rather than a flat or increased budget, NASA actually saw a 2% cut. It was quickly realized that there was not going to be enough funding to keep everything going. While some things like Mars sample return were in clear and spelled out danger, other issues would require further analysis. For instance, according to a review by the American Astronomical Society, the cuts proposed to the Chandra Space Telescope imply the mission will need to move into closeout operations as the budget doesn't provide sufficient funding for science, operations, and other costs to be covered. They also found no path forward for Hubble that didn't require significant cuts to mission operations or science support. NASA officials have stated in a variety of venues that they wish to protect in-progress missions over future missions and even, to a degree, new science. This has been reflected through delayed and canceled funding proposal deadlines, which means that new missions won't be started on previously expected timelines, and new science projects won't have the chance to compete for funding as would normally be expected. It is within this context of budget cuts and desperate measures that NASA found itself with a long-anticipated lunar rover, the Viper rover, that was more than 40% over budget, in need of at least $100 million in funding, and slated to launch on an untested and ever-delayed delivery system. Per policies, this degree of budget overrun triggered an automatic internal review of the mission. On July 17th, NASA announced its intention, based on the review, to cancel Viper and disassemble it so its pieces could potentially be used for other rovers. This would result in an estimated savings of $84 million compared to moving forward with launch. As far as I've been able to discover, this is the first mission canceled so close to launch after such a review. Other missions in a similar position, such as most recently the Psyche mission, have all been allowed to proceed. The loss of the Viper mission was an echo of a prior mission cancellation for many. Early in the last decade, researchers engineered a rover called Resource Prospector. It was developed to the point of prototyping a rover and testing it in the field in 2015. Instruments were developed, and the engineering prototype even underwent thermal vacuum testing at Johnson Space Flight Center. It was reported the final version might fly to the moon on either what would become Artemis II or on a Falcon Heavy. In 2018, however, NASA radically changed how it plans to explore the moon. In April 2018, Resource Prospector was canceled before construction of space hardware could begin. It was intended that the instruments developed for Resource Prospector would fly on a later mission as part of NASA's planned Commercial Lunar Payload Services Program, or CLPS program. Through this program, NASA would pay private companies to deliver instruments and other lunar hardware to the moon on fixed-price contracts. Out were the days of cost-plus-fee missions that would fully fund companies for their construction of fully bespoke spacecraft. In were the days of companies being expected to deliver goods to the moon however they wished, with NASA paying for delivery just as They might pay for something to be delivered cross-country via FedEx. In September of 2018, NASA announced 14 companies it planned to work with, and in May 2019, NASA began awarding contracts. In late 2019, NASA announced the funding of a new rover, Viper, that would leverage what was developed for Resource Prospector as part of a future CLIPS rideshare on what was to be Astrobotic's second lander, Griffin, which was intended to land in 2022. This would be the most ambitious CLIPS launch to date, with Astrobotics being tasked to provide safe delivery to the lunar surface of a $500 million lander on what was scheduled to be only their second lunar landing. And then came a pandemic, along with all the normal delays that impact missions. The launch date slipped to 2024. And then Astrobotic's first lander, Peregrine, failed to even make it to the moon's surface. And then everyone involved realized that a 2024 launch was going to slip, likely to 2026. And on July 17th, 2024, Viper was canceled as NASA stated storing the mission for later use would not be an option. At the NASA Space Exploration Forums at the end of July, multiple NASA officials made it clear the mission team had done everything they could to keep the mission on track and on budget. But this was a mission deeply impacted by factors beyond their control, such as COVID. Due to supply chain problems and other vendor issues, delays initially expected to be measured in days or weeks stretched into months. Costs rose both for the increased costs of goods and also for the increased salary costs as time dragged on. Having finally made it past those hardware delays, the now complete rover was short one ready-to-go launch provider. At the time of its cancellation, Viper was completely constructed and undergoing final testing in preparation for the previously planned September launch. Ground systems were in place to run the mission, teams were trained, and all that was needed was a few more tests. Scientists don't allow their missions to go quietly off into the night. Motivated to act, we have written letters and signed petitions as our networks engage both NASA and congressional officials. When NASA wants to cancel a mission, they have to notify Congress, and the mission isn't totally dead until it's removed from the following year's NASA budget. With Congress currently on recess, it is unclear what will happen, although, per CNN, some lawmakers have expressed concern. It remains possible that Congress will step in and save Viper from disassembly. And even if Congress doesn't step in, there may be a previously never-seen third option for Viper. NASA is willing to see another company or agency take over the mission as long as such efforts come at no cost to NASA. According to both the Planetary Society and Space Policy Online, there have been order of a dozen serious expressions of interest to a NASA call for proposals. CNN is reporting one came from an Astrobotics competitor, Intuitive Machines. Like Astrobotics, Intuitive Machines is a NASA commercial vendor. In a mission earlier this year, which we reported on, their lander arrived at the moon somewhat successfully, although they landed fast and their craft fell over, limiting what they could accomplish. They do have a second mission planned for later this year and are reported to be considering a third, larger lander for 2026, a lander that could carry Viper. The way the Viper mission is evolving is one of the weirder dramas of modern space exploration. It is unclear what kind of fate is working behind the scenes. I don't know if it's more of a Shonda Rhimes or Aaron Sorkinson force of nature. In my personal what-if imagining, I'd like to believe that concern over Astrobotics' lander led someone in power to say to someone else in power, "We need a new landing vehicle." And together they hatched a backroom scheme to see Viper to the moon another way that otherwise couldn't be possible. Headcanon and reality don't often mirror one another, but I'm hoping maybe there will be a safe lunar landing in Viper's not-so-distant future. Whatever Viper's future may be, This mission is a case study on how a researcher can dedicate 20 years of their life to proposing, designing, and building a scientific instrument only to have it canceled in the 11th hour without even having a chance to try and reach space. This is a warning to other mission teams that says clearly no one is safe. Any mission can be canceled and, horrifyingly, can be disassembled for parts. This isn't a lesson any of us needed, but this is where we are. There is no happy ending to this story or this segment. There's just a lesson that nothing is guaranteed. Space is hard. Up next, we look at this week's Tales from the Launchpad. I'm pleased to be able to welcome on aerospace correspondent Erik Madaus for this week's Tales from the Launchpad. Hey, Erik.
Hi, Pamela. On July 4th, China launched the Tianhui 5-2 mission on a Long March 6A from the Haiyuan spaceport in northern China. Let's watch the launch. Tianhui 5 is a constellation of nominally civilian mapping satellites. On July 8th, SpaceX launched the TurkSat 6A mission on a Falcon 9 rocket from Slick 40 at Cape Canaveral Space Force Station in Florida. Let's watch the launch.
5, 4, 3, 2, 1, ignition, and liftoff. Go SpaceX, go TurkSat. Vehicles pitching downrange. Stage 1 propulsion is nominal.
TurkSat 6A is a military communication satellite that will be operated by the Turkish Armed Forces. It is the first communication satellite to be fully built in Turkey. It has a standard design life of 15 years. On July 9th, Arianespace launched the inaugural mission of the Ariane 6 rocket from the Guyana Space Center in French Guiana. Let's watch the launch.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage 2 ESR, décollage. Nominal.
Because this was the first launch of a new rocket, it did not carry a real payload. Instead, Arianespace offered payload space to universities, commercial companies, and NASA, all at a discounted rate. In addition to several permanently affixed experiments to record the launcher performance and 8 CubeSats, it carried 2 re-entry vehicles from Arianespace and the Exploration Company. These were named Space Case and Nix Bikini, named for its minimal capabilities. It didn't even have a parachute. The company has larger demonstrators planned, including one on a Falcon 9 rocket later this year. The launch of Ariane 6 went off as planned after a short delay to troubleshoot a ground system. All critical functions worked flawlessly, including one restart of the new Missy upper stage engine. Ariane 5 did not have a restartable high-performance upper stage engine, which severely limited its capabilities. All of the CubeSats were successfully released into their targeted orbits. When it came time to restart the engine for a third time, it failed to relight. This was determined to be the fault of the APU, a small engine in the upper stage that provides propellant settling and pressurization. Arianespace made the decision not to attempt another restart and instead vent the tanks and battery chemistry to avoid the stage exploding in the future. The re-entry vehicles were not separated to avoid creating more space debris. Overall, a very successful mission with a bummer at the end. The preparations for the next mission will proceed as it does not require an engine restart in the profile. On July 9th was the 5th launch of the Hyperbola 1 rocket by Chinese company iSpace at the Qiuquan spaceport. On board were 2 Yunyao commercial satellites. The launch was a failure after the 4th stage failed to light. If you're keeping score at home, that makes 2 consecutive launches of unrelated rockets with upper stage failures. I don't usually talk about Starlink launches in detail, simply because there are so many of them and the show has a target time to hit, but I'm making an exception for this one. On July 11th, SpaceX launched the Starlink 9-3 mission from Vandenberg Space Force Base in California. On board were 20 Starlink V2 mini satellites. One of the things I like about our new AVSN schedule is that it lets me cover missions in more detail. For instance, this Starlink launch ran into a problem a minute or so into its upper stage burn when large amount of solid oxygen particles were observed flowing out of a tear in the stage's mylar insulation blanket. Some amount of SOx venting is normal, but not to this degree, so experienced observers were concerned. The burn appeared to end normally, and SpaceX ended the livestream prior to deployment, as is usual for Starlink flights. Later that evening, they confirmed the second stage engine had exploded following its restart due to the oxygen leak. Somehow, the stage remained intact enough to deploy the satellites. SpaceX was only able to make contact with 10 of the satellites, all in a very low orbit, in grave danger due to the high drag. SpaceX CEO Elon Musk stated they were commanding the spacecraft's ion engines to fire at, quote, Warp 9, and investigating the Falcon 9 failure. This was the first failure of Falcon 9 Block 5, and the first Falcon 9 failure since Sierra 7 back in 2015. As the week progressed, the remaining 10 satellites swiftly lost their battle with the atmosphere and burned up. The FAA, initially stating they would not be conducting an investigation, later confirmed that the Falcon 9 was grounded, pending a public safety investigation. This could have been catastrophic. Falcon 9 is a world's load-bearing rocket, responsible for the U.S. only certified crew and both cargo resupply spacecraft to the ISS, and basically the only choice of launcher for a whole bevy of commercial and government customers around the world for near-term rocket launches. Fortunately, the ISS is in a good state consumable-wise, so it could weather the drought. SpaceX began immediately pressuring the FAA to allow them return to flight, with a request coming 4 days after the failure. It was denied. SpaceX finally got a waiver to return to flight on July 25th while the investigation proceeded. The FAA is also still reviewing the Starship IFT-3 flight investigation. How can they do this? The regulatory environment for commercial spaceflight in the U.S. is very restricted due to a law called the Learning Period, set 20 years ago in the Commercial Space Launch Amendments Act of 2004. It essentially prevents the FAA from doing all but the most minimal public safety reviews on commercial spaceflight while they and the industry figure out what regulations are needed. What this basically means is SpaceX is allowed to do basically whatever it wants short of seriously injuring or killing an uninvolved member of the public by dropping rocket parts on them. The Falcon 9 rocket successfully returned to flight on July 27th, 15 days after its failure. It is still not cleared to fly NASA astronauts or ISS cargo while NASA reviews the investigation in more detail. There have been 6 launches of Starlink satellites since the failure, all successful. On July 18th, China launched the Gaofen 11-5 mission on a Long March 4B rocket. Let's watch the launch. Gaofen 11-5 is the latest batch of satellites for the China High-Definition Earth Observation System constellation. It's used by the Chinese government for ostensibly civilian purposes such as land surveying, urban planning, and crop yield estimation. On July 30th, United Launch Alliance sent the USS F-51 mission on its way under the power of the last Atlas V to carry a U.S. government mission. Let's watch the launch.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition and liftoff of the United Launch Alliance Atlas V rocket, carrying USSF-51 for the United States Space Force on ULA's 100th National Security Mission.
Hydraulics look good. We are throttling down in preparation for max Q.
No details about USSF-51's payload were disclosed, but the mission motto was Alles grav nils, which may translate to nothing is heavy with wings. USSF-51 was originally slated to launch on a Vulcan Centaur rocket, but was moved to Atlas due to delays in certifying that rocket for government payloads. On August 2nd, Rocket Lab launched the Owl for One for Owl mission from their Mahia Peninsula spaceport in New Zealand. On board was the fifth satellite for Japanese company Synspective. Synspective operates a constellation of radar satellites capable of 1 meter resolution imagery. The company's constellation will eventually number 25 in size. This was the third operational satellite. Rocket Lab previously launched both development satellites for Constellation as well. We keep track of orbital launches by launch site, also called spaceport. According to RocketLaunch.live, so far this year, the United States has had 84 launches, China has had 34 launches, New Zealand has had 8 launches, Japan, Kazakhstan, and Russia each have had 4 launches, India, Iran each have had 2 launches, French Guiana and North Korea each have had 1 launch. This makes the total number of launches this year so far 144, with 4 failures.
Thanks, Erik. We try really hard to end every episode on a high note, and after the bad news around Viper, good news was more necessary than ever. So here goes. NASA periodically transmits cultural content into space, from music to a recording of a human heartbeat on Voyager's golden record. Who we are as a planet spanning civilization periodically gets beamed to the stars. And the variety of what is getting sent out just got a bit more hip to the beat. For reasons I can't explain, NASA pointed its deep space network at the planet Venus and transmitted the lyrics to Missy Elliott's song, The Rain. Venus, by the way, is Missy Elliott's favorite planet. Because of how radio beams spread out as they travel, some of this signal will have continued on toward the outer solar system and will eventually make it to the stars beyond. In all likelihood, the signal can't be detected at stellar distances because it just won't be that strong. But it's still fun to imagine being greeted by aliens who start with the opening line, beep beep, who got the keys to the Jeep vroom? As a lover of Jeep Wranglers, I'd be okay with that. Other lines from that song, well, things could get a little weird on the D-Lo. All right. Good night, everyone. And remember to go out and look up. Oh, and please give this video a like and subscribe. Your clicks and comments help us get science into more brains.